Question 38. Calculate the percentage of available chlorine in a sample of 3.546 gram of bleaching powder which was dissolved in 100 milliliter of water. 25 milliliter of this solution on treatment with potassium iodide and dilute acid required 20 milliliter of 0.125 N sodium thiosulphate solution. Now bleaching powder, that is CaOCl, Cl, when treated with potassium iodide will liberate iodine and chlorine gas. Now this iodine on treatment with sodium thiosulphate, that is Na2S2O3, will form Na2S4O6 plus NaI. Now, as can be seen from the equation for the reaction, equivalents of bleaching powder will be equal to equivalents of iodine, and equivalents of iodine will be equal to equivalents of chlorine, and equivalents of iodine is also equal to equivalents of sodium thiosulphate. Or it can also be said that equivalents of chlorine is equal to equivalents of sodium thiosulphate. Now the volume of the bleaching powder solution taken is 25 milliliter. Now equivalents of chlorine in 25 by 1000 liters of solution is equal to equivalents of sodium thiosulphate. Equivalents of sodium thiosulphate will be equal to normality of sodium thiosulphate, that is 0.125 N, into volume of sodium thiosulphate in liters, that is 20 divided by 1000 liters. And from this, the equivalents of chlorine in 100 by 1000 liters of solution will be equal to 0.125 into 20 by 1000 into 1000 divided by 25 into 100 by 1000, and this is equal to 1 by 100 equivalents. Now we know the equivalents of chlorine. Therefore, weight of chlorine will be equal to equivalents of chlorine, that is 1 by 100, into equivalent weight of chlorine. Now equivalent weight of chlorine will be equal to molecular weight of chlorine, that is 71, divided by valency factor of chlorine, that is 2, and this is equal to 0.355 gram. Therefore percentage of chlorine will be equal to 0.355 gram divided by weight of the bleaching powder, that is 3.546 gram into 100, and this is equal to 10.01%.